So for number 12, you need to identify the key features, reminding you what they are: the vertex, the axis symmetry, the max-min value, the y-intercept, and the x-intercept, or seps. For number 12, this function, f of x is 9 times the quantity x plus 5/3 squared minus 4. Alright, let's get to it. Here's the function, and you should notice right away that this is in vertex form. We have a group squared. This is our a value, so we have a x minus h. We have a translation there and a translation here, and this is our a value. So vertex form, that's where we begin with the vertex. Our vertex is at, let's go back to what we know about transformations, particularly translation. This shifts the graph to the left 5/3 of a unit, or 5/3 unit, and then down 4. Alright, so there's our vertex, negative 5/3, comma, negative 4. Well, now that we have our vertex, we can easily write the axis of symmetry. The axis of symmetry passes through the x coordinate of the vertex. So in previous videos we used the axis of symmetry for the vertex, then to find the y, but in this case we use the vertex to find the axis of symmetry. Alright, so let's box our key features. That's the axis of symmetry. This is our vertex. And now we can determine the max or min value. First, let's determine if we have a max or a min. Our a value is positive, so drawing a nice little picture to remind us. If you have a positive a, you have a parabola that opens up, which implies we have a minimum value, and our minimum value is negative 4. It's the y coordinate of the vertex. If you haven't already, I definitely recommend you go back and watch video number 10 and 11 for questions 10 and 11, because all of these overlap. All of these key features overlap. Just depends on the form. Depends where you start. So in this problem, all we need to find now is the intercepts. Starting with the y-intercept, we're going to sub in 0. Substitute in 0. Alright, so here's our function, f of 0. Alright, let me color code that quickly. F of 0, input 0. Alright. I want this color. There we go. F of 0. Is 9 times, I'll put the 0 in a second, plus 5/3 squared minus 4. So I want to find this. Alright, let's do it. Without a calculator, order of operations, start with your parentheses. Well, this is not too bad. 5/3 squared minus 4. Right, now we take care of the exponent. 5/3 squared. 5 times 5 is 25. 3 times 3 is 9. There we go. Minus 4. And we get a nice little simplification because the problem's rigged that way. 9 times 25 divided by 9, 9 times 25 ninths. Those undo each other. We're strictly left with 25, take away, oh shoot, 25 minus 4, which is 21. So our y-intercept is at 21, or we can write that 0, 21. Whenever you input a 0, you output the y-intercept. So I'll box the coordinate. Onto the x-intercepts, which I'll need a little bit of room. How do we find this? We are not going to use the quadratic formula. The quadratic formula is when we have standard form, because the quadratic formula requires an a, b, and c value. But here we have a different form. We have a, h, and k. Well, that should be a k. Sorry about that. Let me undo this right here. Erase yourself. Just notice this. The form is k. Alright. Sorry, that's from before. No big deal. Moving on. So how do we find the zeros? We work backwards here. use the definition of a 0. 0 is the output, 9 times x plus 5/3 squared minus 4. And now we just work this problem backwards. We have, here's some number. It's being added by 5/3, then squared, then times 9, and finally minus 4. So working backwards, we'll add 4 to both sides. And on the left we get 4 equals 9 times the quantity, x plus 5/3 squared. So start with a number, add 5/3, square it, then multiply by 9. Well, last thing we did was multiply by 9, so let's undo that. Divide both sides by 9. And on the left, we get a fraction. That's pretty peculiar. 4 and 9, both perfect squares. Let's see how this all plays out. X plus 5/3. Oh, my alarm's going off. I'll write it like this: 5/3 squared. So x plus 5/3 then squared. Undo the squaring by taking the square root. We are in algebra, so we do want our positive and negative value. Here, there's two numbers that multiply to 4/9. Positive and negative, well, square root of 4 is 2/3. Let's check that really quick. 2/3 times 2/3. 2 times 2 is 4. 3 times 3 is 9. Great. And negative 2/3 times negative 2/3, well, that's also positive 4/9. So there's our two values. And on the right, we just have x plus 5/3. So final step here is to minus 5/3 on each side. It's really driving me crazy. Minus 5/3. So we got to be careful just thinking about what we're doing. So I'll clean this up. So we have negative 5/3 plus 2/3 as an x-intercept, or a 0, and we also have negative 5/3 minus 2/3 as a 0 or an x-intercept. So let's clean this up. Oh, we have two fractions. They have the same denominator. Very nice. Add our numerators. Negative 5 plus 2 is negative 3/3, which simplifies to negative 1. And so there's one of our zeros. Or we can write that as, when you input negative 1, you output a 0 as the ordered pair, really as an x-intercept. In this case, negative 5 add negative 2, that's negative 7/3. And that doesn't simplify, so we'll just keep it as an improper fraction. So as an x-intercept, we could say when you input negative 7/3, you output a 0. And there we have it. So let's go back and check. Do we identify all our key features? Vertex form, one of my favorite forms, gives you a lot of information off the bat. You can easily identify the vertex just by looking at it. This is a horizontal translation. Left, so that's negative 5/3. Down 4, so our vertex is at negative 4. Once we have our vertex, we have our axis symmetry. X equals negative 5/3. We look at the a value, it's positive, so we have a minimum value of negative 4. That was there. Finding their intercepts, we always sub in 0, do a little bit of math, and our y-intercept was 21, and our x-intercepts are at negative 1 and negative 7/3, or we can write them as follows. So let's just check that now that we've done our work. And well, this is an ugly number, negative 1.67, but remember we found the calculator was at negative 5/3, so if we actually see what that is as a decimal, negative 5 divided by 3, that does work out to be negative 1.6 repeating, and with the rounding error, the calculator is just telling us it's negative 1.67. So there it is, negative 5/3, comma, negative 4. Our zeros are at negative 1 and negative 2.3. Remember, our other 0 was as a fraction negative 7/3, and if you have the calculator do the workout, there it is again, negative 2.3 repeating, so our work does check. And if you remember, our y-intercept was 0.21, which there it is. So I hope this helped. Good luck studying.